estimate. If this is very important for you, then you go by this. Otherwise, you can go just put n is equal to whatever is given in your specification or what you find. Okay. Now, if after this acceleration, you can draw a graph like this, just like how you did earlier. Okay. Probably it will be something like this. I don't know the shape actually. This is n is equal to 1, maybe, this is n is equal to 2, etc. If you have a specification, that is now your maximum n is equal to 2, okay, then you draw this in red color. If there is no specification on you, or if it's your own specification, you can put it in yellow or orange color. Okay, just put in yellow or orange. If you specify on your own. If you're ignoring it, either you don't have to do or you don't color it. Okay, all this red color and yellow color will become constraints later. Okay, sometimes some constraints may not be fulfilled. That's why you have to choose among all these things. Then he just put wing loading effect on range. Actually, what he's doing is wing loading effect on speed, you should say. Okay, so just by the definition of CL, you'll get this equation. CL is W by half rho v squared s during cruise. So make use of this. For this, you need the value of CL during cruise. Okay, so how to do this? You can estimate that it is cruising at root 3 naught by 2k, or you might have done some 0.94 L by D max earlier in the weight estimation. You take that as the CL for cruise if you don't know C naught and K at this point. Instead of this CL value, you put the CL cruise you are assumed earlier, 0.94 into L by D max. Okay. And then what is the aim here? To determine WS at cruise. You just determine like this. So this will be a very simple figure. Maybe to be a straight line in this graph. So with a cruise velocity, you can draw a straight line. If your wing loading is more than this, then your cruise velocity will be more than that. The wing loading is less than that, then cruise velocity less than that, which you don't want. Okay, so your feasible region will be to the right of this graph. To the left of this graph, you will have region which is not feasible. Okay, so this is how you play with the graphs. Then wing loading effect on combat. Combat is actually dictated by instantaneous turn rate, which in turn is dictated by n. Don't go through all these things; not really necessary. It is okay if you take that n. So n values of 5 to 7 are fairly typical of fighter combat aircraft, and CL max for combat is not the same as that used for takeoff and landing. So typically, CL max is between 1 and 1.5 for combat. No, instead of going through this, what I want you to do is just plot this sustained turn rate, graph. That's good enough, because you just need to have an understanding of what's happening. Don't get lost in too much in this nitty-gritty details. When you specialize in design, you can go through all this. Now this wing loading, you get the same expression except that there's a n term here, 4n squared. This n squared terms are missing in the earlier solution. You get a graph between T by W and W by S. That's what you plotted earlier. So for acceleration or for combat, for sustained turn rate, use the same graph. You just use n is equal to the maximum value you have. So all are now clubbed into one graph. Don't need to worry about it further. Then flight ceiling also will have an effect on. The expression is very similar to your your cruise. It's basically based on the velocity CL1. Only thing, the lift coefficient value is different. Okay. Now specified Mach number at wing lift coefficient. So since CL is changing, the wing loading by this, for this will change. Now for ceiling, if you have a how it will do is, that is, you look at this expression. Q has rho in the numerator. If rho decreases, you will have a height which is increasing. So from this expression, we can say that if wing loading is less than something, the selected one, then you can reach the ceiling. If wing loading is more than that, then rho has to be more than that, keeping other things constant. Okay? So it cannot reach the ceiling. That's what it means. So in this graph, hopefully this may be the, or this may be the wing loading for ceiling. This may be for cruise. So wing loading has to be less than this. So here the feasible region will be towards this, and whatever here will not be feasible. Okay. Then wing loading effect on glide rate for those who are doing sailplanes or I think solar plane endurance. I'm not sure whether you can use this, but if you are designing gliders, anyone designing gliders in the group? I don't think I've given gliders today this time. But anyway, you just know what it is. So L by D is maximum when you want maximum range for a glider. So to make this happen, you seek a condition where CL for minimum descent, endurance. This is for endurance during gliding. You go through this, and you can also actually, if it just you can consult your earlier flight mechanics notes also for gliding. That should be good enough if you encounter any constraint on gliding. If you have a problem, we'll discuss. I don't think any of you will have this in your design. If you have, in contact me. Okay. So at the end, okay, finally, now very general for all the groups now. Now you have T by W versus W by S. Now let's say you draw all these important red line ones on the same graph. For example, the initial takeoff and landing, you have some graph like this, and probably the feasible region is upwards, let's say. Then what is the next one after takeoff? For climb. Suppose you have something like this. This is the something like climb. Okay. And the feasibility region is down, let's say. I'm not being very accurate here. I'm just giving you some. So I'll just mark off the region is not feasible. This is not feasible because of I say takeoff. Then this is not feasible because of say climb. Then because of acceleration, probably you may have some other condition. Say n is equal to 3, which is due to acceleration, combat, everything. And you say, I'm just figuratively only suppose you say only this is feasible. Okay, then that will say that whatever is here is not feasible also. And then for landing, you say, you put it in green if there is no landing constraint, but you're choosing it yourself, which means you can move it left and right if you want, so that you will know which one you can move out. So landing is here, and you say, wing loading less than that is not feasible, for example. So this area also goes off. Then for cruise, let's say, you have only, only beyond this is possible. Okay, it's already excluded. So it is in this case, it is subsumed by the landing one. Then for ceiling height, suppose you say that something only left of this is possible. The right is not possible. So now, if you put all the conditions which you have for aircraft, you will get the feasible region in this graph is only this one. Don't you agree? Which satisfies all these conditions. Isn't it? Dev Sultan.
Yes, sir.
So you have to choose your wing loading within this feasible region.
Yes, sir.
Typically, if other things don't warrant anything else, you'll choose a wing loading, okay,
Yes, sir.
as high as possible, and the thrust load T by W as low as possible. Now it is in conflict. If you want wing loading as high as possible, you have to take this point, correct?
Yes, sir.
If you want to take T by W as low as possible, you have to take this point.
Yes, sir.
So you make a compromise. Based on your judgment, you determine which of these is very important for you. The green one is not important, okay? But suppose the red one is important for you, it should be nearer to the red one. So probably this may be good, or somewhere here may be good, okay? You make the judgment, but it should be in the feasible region,
Yes.
okay? And suppose you have chosen this, then you choose this as your wing loading. The wing loading chosen, wing loading finally chosen is how much? Let's say 500 Newton per meter square. Okay, just figuratively. I am fixing the wing loading here from this graph. My job is over. That's all. Wing loading you can do now. Understood? Any doubts? You can go through this and ask doubts if you have. Right now, do you have any doubts?
Not right now, sir. I'll have to go to Thomas Kirk again.
Yeah. Whenever you get doubt, you can ask. In fact, your presentation starts tomorrow.
Yes, sir.
So all of your classmates will help you. Okay.
Okay, sir.
If I don't help you, we'll see whether they are helping you. Then, if possible, I will help you. Okay.
Okay, sir.
Okay. Good. So I'll just be the moderator. You will carry on from tomorrow. So once some group says, sir, I have finished weight estimation. I have nothing to do. Don't worry. Go to wing loading immediately. Okay. So,
Okay, sir.
right. So tomorrow, shall we decide which groups are presenting tomorrow? Sandita, Sandita is here. Sandita, I think she's not here today.
Yes, sir. We can.
We can decide. Yeah. So I think tomorrow group 4 can start. Okay. So we'll I'm not keeping track of this. Sanjay, please keep track and inform Sandita.
Sure, sir.
Okay. So we'll just 5 presentations. Just put the date inside. Okay. First will be group 4.
Okay, sir.
Then group 6, group 9, group 11, group 14. I don't think we can accommodate more groups there. Okay. I think
Yes,
5
sir.
groups is more than that. So these groups, please be ready tomorrow. So one person from each group should be presenting. That person, okay, there will be some, okay, 25 marks for presentation, or rather, I'll devise a way. We will devise a way right now. Okay. Weight estimation. Who's presenting now? For group 4? Who's group 4? We'll also put the, the aircraft name here. Group 4, who is anyone? Here now?
Group 4 is water bomber, sir.
Water bomber. Who's presenting tomorrow? This weight estimation thing.
We haven't decided yet, sir.
Okay, tell me tomorrow. Tomorrow I'll put the name here because I have another Excel sheet. I'll give marks for the presenter separately and the group also.
Okay.
Okay. So the presenters will get, you will be presenting for how many times? Four in the group, no? So everyone present 3 times. So I'll say for the presenter, I'll give 100 marks. So for presentation, okay. Each presenter will get 300 marks totally. Everyone will get 300 out of 300. Whatever you do for presentation, you'll get. Okay. And for the report, we'll have 25 marks per report. So 25 into 12. That will become again 300. Then for the presentation, each group will get again 25. For example, based on the presenter's skill, the group itself will get something out of 25. So again 25 into 12, 400. So these will be the marks split up. Okay. So suppose Kevin is presenting tomorrow. He will get marks out of 100 separately, and he will get whatever his group gets for 25 marks also. Similarly for everybody. Okay. Now, just let me know who will be presenting. Group 6, what aircraft do you have?
Amphibious aircraft, sir.
Amphibious. Who have you decided who is presenting?
Not yet. Sir, I think I'll be presenting tomorrow. Krishna.
Krishna. Roll number is
22.
okay. So 9, group 9. Who is group 9? Group 9, no one here.
So,
Hmm.
short haul aircraft.
Short haul aircraft. Yes.
Yes.
Regional aircraft, you mean?
Yes, sir. Yes.
Okay. See. Right. So now, which roll number have you decided will be presenting?
Sir, 26, sir.
26. Who is that?
Sir, Nitin.
Nitin. Okay. Group 11.
Yes, sir.
Hmm.
Military transport aircraft.
Roll number.
We haven't decided yet, sir, who's going to present.
So anyway, if you don't decide anybody tomorrow, I will choose someone on my behalf and give them 0 if they don't present. Okay.
We will decide by the end of the class, sir.
Yeah. Okay. So then group 14.
Sir, Solar's pipeline.
So was piping. So you have to design your own methodology. Okay. You don't need to present
Yes,
rate
sir.
estimation. You can actually tell what is your methodology you are going to follow.
Okay.
But at the end of the thing, you have to make 12 presentations for the whole design in whatever order you want.
Okay, sir.
Okay. Yeah. So who's presenting tomorrow?
We haven't decided.
Okay. So please decide. Someone has to present. Then weight estimations tomorrow. Okay. The date we'll put within bracket. Okay. Weight estimation I will put here because there will be 2-3 days in which all groups present. Okay. I'll copy your roll numbers and team or all those things I will do later. Or I may have another Excel sheet for that. Can I use this for rough work? Okay then. So then now, Krishna, you have something to share?
So nothing interesting.
Something. I mean, what are the news today? I don't read newspapers.
I haven't read the news for today, sir.
Yeah. Whatever. I didn't read yesterday also. Yeah. So you can see.
Sir, can I think about it for a few minutes?
Yeah. No, not minutes. 2 seconds.
Oh, seconds. Okay.
Today
Sir,
India
so
lost to Belgium in hockey, sir. In
India.
semi-finals. Lost
Ah.
to Belgium in hockey semi-finals men's, sir.
Who's telling this?
Dave, sir.
Dev, let her tell something.
Yes,
Krishna.
sir. I just wanted to tell the news for today.
Good, very good, very good. So, will you be playing for bronze against someone else later? Is it there or no bronze? Dev,
Sir?
will you be playing another match for bronze medal?
Yes, sir.
Okay. Is it confirmed or we don't know the opponent yet?
Sir, by today 3:30 p.m. next match will be there, sir.
Okay. Okay, Krishna, come on, something.
Yes, sir. Yesterday I watched a video about the scoring rubrics for Olympic gymnastics competitions.
Oh, okay.
So, in that, there's this kind of complicated spinning maneuver that they call a wolf turn.
Wolf turn, okay.
So, when they balance on a bar and they place one foot outside outstretched, and their axis of rotation is the other foot.
They
So,
balance on a ball.
on a bar, sir, on like a beam.
Bar. Wow. Okay.
And
okay,
they
yeah.
put one foot and they stretch the other foot out. And they
Oh.
were talking about how when they spin to decrease the moment of inertia, they bring their hands close together, and to stop as soon as 3 spins are done, they stretch their
They-
hands back out.
Momentum
So
inertia.
based on that,
So what
they
is
score.
constant there? What is constant there?
So they stay in the one foot stays in one position, so their axis of rotation, they anchor themselves on one foot.
No. Physically, angular momentum is conserved.
Yes, sir. Angular momentum is conserved. Yes, sir.
So I times
Omega.
omega. I omega. Correct. So this is very important for space flight mechanics also. Very good.
Okay, sir.
Because same thing happens when a body is rotating around. For example, a planet is rotating around sun, a satellite is rotating around Earth or any planet. Same principle. Angular momentum is conserved. Simple. Because
Yes.
angular momentum is a vector. Angular momentum is a vector. It's not a scalar, right?
Yes, sir.
Agree with me. How? I omega, where is the vector coming from?
Omega.
Omega vector, where does it point? Suppose it's rotating.
Tangent of this. Isn't it
Tangent.
tangent?
No. You put your fingers around the rotation, then the thumb points the direction of omega.
Oh, okay.
Like your right hand rule.
Yes, sir. Yes, sir.
Then that vector is constant.
Okay.
The magnitude I omega is constant, okay? Right? But
Yes, sir.
the direction of vector also cannot change because it's more deeper than just the magnitude. It says the vector also cannot change.
Okay.
So because of this, we get a very interesting result that the plane in which a planet is orbiting around sun, for example, does not change.
Okay.
Because the plane changes, the direction of omega will change even if you keep the magnitude same.
Yes, sir.
Correct? Yeah. Same way, because the magnitude, if you look at it, then instead of I omega, we have something else there. Okay, I just a point mass if you consider. This is the same reason why things speed up when they're near the sun, and they slow down
Yes.
and they go away from the sun to
Okay.
keep that angular momentum constant. So interesting. What are these rubrics actually?
So based on difficulty of the move that they've executed, they are given a certain amount of points.
Yeah.
And the grace with which they execute it and the dynamics of the move, all that has points.
Certain points, yeah.
Yes.
Similarly, we also have rubrics for your final year presentation. Okay.
Okay, sir.
When you present, we see how much marks to give for your presentation skills, how much marks for clarity of your work, and how much mark for the quantity of work you have done, and how much mark for the quality of work you have done. So like this, we have rubrics, okay, for your things. That's a use the right word. I had to talk so much about it. Although you speak late, you speak wise words. Good.
Thank you, sir.
Good. Thank you.
Thank you, sir.
So we'll, if there are doubts you can ask now. We have some time.
Sir, one general doubt, sir.
Uh,
Sir, a report also should be submitted on the same day as when we do the
no,
presentation.
no. Because in presentation, I understand you may have doubts.
Yes, sir.
Okay. People might have finished only half the work. So they can present up to what stage they have done. If they have doubts, they can ask in the presentation.
Okay. Okay, sir.
People can ask doubt in the presentation. It won't adversely affect you in any way. It depends on, finally some rubrics which I have. Okay.
Yes.
So,
Yes.
so you can't do anything. I mean, if you don't do anything and say that, sir, I don't know anything, explain everything, then you will get zero for presentation.
Yes, sir.
If I understand that, you're trying and, you have reached some stage, you have some difficulties, yes, you won't lose marks because of that.
Okay.
But so report, the due date will be, 1 week from the first presentation. So, for example, it will be due next Wednesday for all groups.
Okay.
So, if some groups still don't finish the presentation, even they have to submit the next week.
Okay, sir.
Meanwhile, the other presentation will start. The second one will start. Once this is over, we
Yes.
won't wait for you to submit the report, but the next person in the group should be ready for the subsequent presentation.
That is wing loading.
Wing loading, yeah. Wing loading.
Okay, sir.
In between, you may get some breaks. Okay, some kind of breather time and all those stuff. Then there are natural holidays which fall under the way. Or, I may want to explain something and take a class. Okay. So, you will get some breather time in between. These are the simple reports. So 1 week is more than enough. Okay. Yeah, when you start doing it, you get some more reports, some more doubts. I understand. That is why during after presentation, I'll give you still some time to correct. Okay, the other groups, please decide who's presenting and tell me tomorrow.
Sir,
Yeah. Any other
group
doubts?
11, roll number 28 will be presenting. I will be presenting.
Pawan, group
Yes,
number
11, roll number 28.
28. Fantastic. Pawan. Okay, good. Group 4 and 14 will get back to me later.
Group 4, roll number 20, sir.
Group 4, Kevin, na?
Yes, sir.
I mean, 20 is Kevin.
Sir, group 14, roll number 45.
Who's 45?
Surya Prakash.
Okay, I'll better write the name also here, easier for me to know. Twenty is Kevin. 22 is Krishna. Let me check my memory power. 26, 28 Pawan too. Pawan, P-A-V-A-N or P-A-W-A-N?
PAVAN, sir.
Good. Then 26, regional shortfall. Who's 26? I forgot.
Nitin, sir.
Huh? Nitin. Oh, okay.
Nitin.
Nitin. Right. Then solar spy plane 45. So told just now.
Surya Prakash.
Surya Prakash. Yeah. What is Surya Prasad's roll number?
44.
Oh, just nearby. Neighbor. Your neighbor.
Sir.
Okay. Okay, thank you. So we'll meet tomorrow. If there are doubts, you can still ask.